Hello everyone, very good morning and good evening. Welcome back to the session and let's get started understanding the auto scaling, load balancing, high availability concepts. As a DevOps engineer, we are responsible in deploying a application which is highly available and which is secured, which is the scalable in nature, right? That's how the end user will get almost like a fault tolerance kind of application, right? So quickly to achieve this kind of the application, right? So we need to take care of deploying your application it into multiple servers. Whenever you have a multiple servers deployed, then the servers must be behind a load balancer. When I'm using a load balancer of type network load balancer here, the network load balancer will actually listen on a specific port, and that will be routing the traffic to the specific target group where the target group is listening on that specific port. That way, any request that comes to the load balancer will actually be sending to the target group. In the target group, whichever the server is healthy, that server will be receiving the traffic. The target group is intelligent enough in understanding which server is healthy, which server is unhealthy. There is a possibility that the server may go for unhealthy due to the security group issue, due to the service is down, due to the important the main configuration file is not available, or whatever the reason. If the server is not able to serve a web page on the port number 80, then I'm going to consider that server is unhealthy. Target group is responsible in verifying the health status of the server. Whichever the server is healthy, only that server will be receiving the request. If the server is not healthy, then that request will not be given to that particular server. That is how the target group will be ensuring that the request is going to the perfect healthy server only to give a healthy response to the clients. So when you are configuring a load balancer, you need to take care of specifying the listener ports, specifying the availability zones that it has to route the traffic to, and have to mention the routing, how and which port has to be routed to which target group, etc, right? So obviously the load balancer will be deployed it into a public subnet, and the servers will be deployed it into a private subnet. And obviously to maintain a high availability, even in case of the zone failures, then we need to deploy our servers it into multiple zones as possible, or if possible. Let's say here I have two servers deployed for my application, and one is deployed into 1A zone, another one is deployed it into 1B zone. When you have a servers which are a targets in the target group or behind your load balancer in different zones, then you must have a load balancer also deployed or associated to the same zones. That means when you have a servers in 1A and 1B zone, then your load balancer should be having associated to at least two subnets. One subnet will be in 1A zone, one subnet will be in 1B zone. Why? If one zone is corrupted or not working for some reason due to the entire data center, right, is having some trouble in giving the services, then your business will continue to be accessible through another zone, as the load balancer also created to have a services in both zones, and the servers also created to service to provide a services in from the both zones, correct? So that is how the basic setup. But here the servers that I am putting it into a target group, those servers are not the constant servers, right? That means if more load comes in, then if the two servers are not enough to suffice or to provide a services to the users, then I should have a auto scaling solution. That is how the target group will be now connected to the auto scaling group, so that The auto scaling group will take care of deciding how many number of EC2 instances has to be available for to serve the application to the users, right? So we already familiar that the auto scaling has the concept of launch configuration, concept of scaling policies. So with the help of the CloudWatch alarms, right, which are configured in the scaling policy, the auto scaling group will be doing the scale out or a scale in, and it will decide the number of EC2 instances to be a match to a minimum, match to maximum, or in between the minimum and maximum, which will be now called as a desired number. So that number of servers will be maintained in the auto scaling group, and how many servers will be available in the auto scaling group, that many number of servers will be available in the target group automatically, and that servers will be distributed the traffic. So to deploy this entire infrastructure, maybe we need to start from the basics. Maybe I'll show you this demonstration start from the VPC, correct? So let me go ahead and start creating a VPC, and I'll start creating the required subnets, and I'll start creating the load balancer, target group, launch configuration, CloudWatch alarms, auto scaling group, maybe SNS topics. There are a lot of resources that I need to create to deploy this particular architecture. Then you will get an application, web application having a highly available, a scalable, a secured. Why it is secured? Because your servers are deployed it into a private subnet, and obviously the servers is secured compared to the way how you deploy it into the public subnets. This is just a repetition of what we have discussed in a previous lecture, correct? Now, let's get into the deployment, guys. Quickly, I'll go to AWS Management Console. I'll start creating a VPC first, okay? I'm going to create a VPC to deploy my web application. Let me call this as DPT4 VPC1. Maybe I'm creating a VPC with 192.168.0.016 is the class B CIDR range. And let me go and create a VPC. Right. Once the VPC is created, now we need to create a subnet. We need a private subnet. We need a public subnet as well. So let me go and create a subnet, and select the VPC, and give the name of the subnet. Let's say DPT4 private subnet 01. So this subnet is associated to 1A availability zone, and the subnet range is 192.168.1.0/24, which is the class C, which is the a subset of the VPC range, and create a subnet here. Well, so let me create one more subnet here, and this time I'm creating a subnet in the same VPC, and my subnet name is, let's say, DPTF4 private subnet 02. I need at least two subnets here, right, to deploy my servers. One will be in 1A zone, another will be in 1B zone. That is how I need to have my servers running. So I'm just creating a second private subnet which is associated to a 1B availability zone, and the subnet range is 192.168.2.0/24. By this time, if you have already familiar with the VPC concepts, then this creation is very straightforward. So I have got two subnets now. Now let me go ahead and create a one more subnet, and select the same VPC, and this time I'm creating a subnet for the public purpose. The public subnet that I'm associating to 1A availability zone, and the subnet range will be 192.168.3.0/24, and go ahead and create a subnet. So let me create one more subnet here, and which will be in the same VPC, and the CADR, sorry, the subnet name will be DPT4 hyphen. This is the second public subnet that I'm creating, and this will be deployed it into 1B availability zone. As I have the private subnets in 1A and 1B, I'm having the public subnets in 1A and 1B only. Then only it can route the traffic to those availability zones. This time the subnet range will be 192.168, let's say 4.0/24, and go ahead and create a subnet. When you are creating a subnet, right here I have created 4 subnets. Let me search for the word called DPT4. That is where you can see all the 4 subnets. The subnets by default will not be decided as a public or a private. To make them public or a private, we need to have a associated route table. Before I go ahead with the route table, let me go and create a internet gateway. The internet gateway is the one which is connected to the internet. The internet gateway will be associated to your VPC. So DPT for IGW01. So this is the internet gateway that I'm creating. This internet gateway must be associated to the VPC level. Select the VPC from the drop down and attach the internet gateway to the VPC. By default, when you are attaching a internet gateway to the VPC, all the resources within the VPC cannot use this just like that. We need to maintain a route table accordingly to route the traffic to the internet gateways. So hence the reason we need to create a route table. Let me have a route table. So let's say this is the route table for the public purpose. Let's say I'm just creating a route table for the public. Select the same VPC and click on create a route table. As we know, by default, the route table will have a route entry routing the traffic to within the VPC via the local gateway. But we need to edit the routes and we need to add a route, and by default, all other traffic will go through the internet gateway. So when you are choosing the internet gateway here, then this route table will become the public route table. And this route table I wanted to use by my public subnets. That is where we need to attach a subnets here. So edit the subnet associations and let me choose the public subnets, which subnets that it has to use this public route table. I'm selecting the both public subnets here and save the association. So now those 2 subnets become the public subnets. Now I can have a one more route table created, and the second route table that I wanted to use as a private route table. So let me create a one more route table, let's say DPT4 route table for the private purpose. Deploy this route table it into the same VPC and create a route table. Right, and by default the route table has a entry to route the traffic via the local gateway if the destination is falling within the VPC, and I'm good with this. This route table should be used by my private subnets. That is where we need to go and edit a subnet associations, and this time I'm choosing the private subnets from the list, so that these 2 private subnets will be using this private route table, as the private subnets would require a outbound internet connectivity to download the packages or so on so on. So we need to have a NAT gateway. The NAT gateway must be associated to the route tables. So let me go ahead and create a NAT gateway here. So I'm going to create a NAT gateway now, and here let me choose the name as DPT4 NAT. So the NAT gateway must be deployed it into the public subnets. So you can choose any public subnet that was already configured some time back. We can see DPT4 pub01, which is the public subnet, which is already having a routing to the internet gateways. And the Nat Gateway would require a elastic IP. Let me pick a elastic IP by clicking this option. Now create a Nat Gateway. The Nat Gateway will take some time to create it. By the time we can go back to your private route table and update the private route table, right? So we can see here the private route table. We can see the routes. We can edit a route and add a route. By default, the traffic, if the destination is not belongs to the VPC range, the traffic now should go through the NAT gateway, and this is the NAT gateway that we have created some time back. So the private subnets will now get a outbound internet connectivity and can have access to the internet. So with this, the VPC setup is completed. We have all the VPC components that are required for me to deploy my computing resources. Now, let me go back to the AWS Management Console, and this time I'm going to set up my load balancer, target group, and auto scaling group. Whatever I have done so far in the VPC is all what we did already. Hence the reason I quickly went and start created the VPC layer. Now let's start creating a auto scaling group. In the EC2 service, if you do a little scroll down, you can see the auto scaling concept here. In the auto scaling concept, you can see there are two options are available. One is the launch configuration, one is the auto scaling group, right? So we need to go for the launch configuration, and if you are creating a launch configuration, in the launch configuration we need to provide all the necessary information how a new server has to be created by the auto scaling group, including the IAM role that it has to use, correct? So maybe you need a IAM role that has to be specified in the launch configuration. So let me do that as well quickly. So now I'll just go to the IAM service to create a role. I'm just preparing the required stuff before I go ahead and get started with creating a launch configuration, right? So the role that have access to the S3 would be required for my EC2, because EC2 has to download certain important configuration files from the S3 bucket as part of the launch process, which is configured in the user data, right? So hence the reason, let me create a role here. And of course, I have created a role already, but I just wanted to put everything together today. So EC2 is the a trusted entity where the role will be assigned. So now let me choose the policy. Let's say I'm just giving the S3 a full access policy for now, granting the complete access to the S3 services or resources. So let's say this is DPT4 S3 full access. That is the name of the role, and scroll down and just click on create a IAM role. Well, so once the role is created, now I'll go back to the EC2. In the EC2, now let's get started creating a launch configuration. So here you can see the option to create a launch configuration. Let me give the name of the launch configuration, DPT4 auto scaling group launch config. So this is where you need to supply the details how a EC2 instance has to be created as and when needed by the auto scaling group automatically. All the options that you see here, all these options are exactly like how you create a EC2 server, but we are not creating a server now. We are just mentioning the details of the server configuration, how it has to create a server later as and when needed. It is asking me what is the AMI that you need to use. So we need to search for the list of AMIs available here and choose the AMI that you would like to attach to your server. So this is having some kind of the problem with the filtering, right? So what I do, right, I'll just go and bring my AMI ID from the different tab. Let's say here I'll just simply go to EC2, right? So here I would like to take the AMI ID which I wanted to use for my auto scaling groups. So if you have a golden AMI already, we can choose the golden AMI. If you don't have a golden AMI, then you need to pick up from the Amazon provided list. Let's say here I'm just going for this particular AMI, which is the Amazon Linux 2 AMI. I can see the AMI ID here. I'm just taking that ID, I'm just searching for that ID because the searching is not so much great. Now I can find my AMI here. Let me choose that. So this is the AMI that I wanted to use, and what is the instance type? Click on choose the instance type. Let's say I want to have a T2.micro instance type. Select the T2.micro instance type, scroll down. Then it is asking for the IAM role. Which role has to be attached to this EC2 server? Select the role that you have created some time back. And we can see something called advanced details. In the advanced details, it is asking for the user data. This is where we need to specify what script that it has to run automatically to bring up your services. And I think we have already discussed about the user data. This is you need to put exactly what commands that it has to run automatically to make your website live. Let's say we need to specify the shebang notation that the command should run from the bash, and let's say yum install hdpd, the one which needs to be installed, a service hdpd start. Maybe I want to download my important configuration data from the S3 buckets. So now let me go and pull the S3 bucket details, in which S3 bucket my information is available from where it has to download. I'm just using multiple AWS resources in this session. I'm just trying to do a logical relationship of all. So let's say here I'm using this DPT4 web data bucket. So this bucket don't have a index.html at the moment. Let me upload that. So I'm just uploading the required configuration data to my S3 bucket that will be pulled by my EC2 server as part of the launch process. So this is the bucket where my configuration is available, right? And in that index.html is the file that I wanted to download, and that has to be downloaded to where www.html location. The command is AWS S3 CP. Because the IAM role was already granted, right? The EC2 can have access to S3 to download this file. Once you are done with this particular configuration script, then keep that configuration script in the user data. Now scroll down. Let it have its own default root volume for now. We don't need any additional volumes. And the security group, let me create a new security group, and I want to allow the port number 22, and I need to allow the port number 80 as well. So let me search for HTTP port number 80, allow from anywhere. Scroll down. So this is where the key pair has to be given, and let me use the existing key pair and I do acknowledge. That is how you are choosing exactly the configuration, how the server has to be created, and you just create a launch configuration. I'm not creating a server now. I'm just creating a launch configuration. That way, all of this configuration is just saved as a configuration. Now, using this configuration, now I'm planning to go and start creating a auto scaling group. For now, if I show you the EC2 dashboard, if I go to the EC2 dashboard, if you see the list of running servers, currently you could see only one server which is labeled as Jenkins, something like that. It was using for different purpose. We don't have any other servers, right? Now, let me go and start creating a auto scaling group. Click on auto scaling group option here. Now click on create auto scaling group. While creating a auto scaling group, you can see that there are at least 7 steps are available, and we need to provide the necessary information how a auto scaling group has to behave or functional for your requirements. Let's say I need a auto scaling group. My auto scaling group name is DPT4, let's say ASG. The name could be anything, not a problem. So here I am using the launch configuration method. So let me click on a switch to launch configuration. Choose the launch configuration from the drop down. This is the launch configuration that I have created some time back, which was saving the EC2 configuration details. So this launch configuration will tell to auto scaling group how a new server has to be created, right? So once you attach a launch configuration to the auto scaling group, go to next. The second step is all about choosing the network. Let's say tomorrow, if there is a more demand, then the EC2 server has to be created where? So we need to tell that the new server has to be created in which VPC, the new server has to be created in which subnets. Tell me guys, here should I need to use the public subnet or a private subnet? So it must be a private subnet because my auto scaling group should be creating the servers in the private only for the security reasons. So I'm choosing DPT4 private 01 from the drop down. Maybe I'll choose the other one, DPT4 private 02, so that when a auto scaling group is creating the server will be deployed it into any one of these two subnets. And go to next. The step number 3 is all about a load balancing, right? So if you go back to this architecture, right, here we know that the auto scaling group must be associated to the target groups, correct? So as of now, I have not done anything to the target group or a load balancer. We don't have this available at this time. So when I'm creating a auto scaling group, I will leave this option for now. I'll come back to this option. I will edit it once we have a target group and the load balancer are ready. At this time, I don't have any load balancer. I don't have any target groups. So I'm just simply skipping this step number 3 by choosing a option called no load balancer. I'll come back later and I'll attach this to a load balancer in a different way. So for now, let me choose no load balancer because I have not created any load balancers yet. So go to next. The next option is all about the group size. We have discussed about desired minimum maximum. So we need to specify the minimum number of servers that it has to run. We need to specify the maximum number of servers that it has to maintain in a auto scaling group based on the demand. The design number will be auto updated by the auto scaling group automatically for you. By default, the desire will be equal to minimum and it will be changing as and when the more load comes in. The minimum 2 is recommended so that at least you will be having two servers. One will be in 1A zone, one will be in 1B zone. So that is a minimum recommended number of servers. However, it is up to you. Maybe if you want to get started with one server as a minimum, yes, we can go for one. And later when more load comes in, then one server will become the two server, two will become the three server. That is how the incrementally the number of servers will be added horizontally. So for now, let me get start with one as a minimum number of servers that it has to maintain in a auto scaling group, right? So now you can see the scaling policies. As I need a scaling policy, so select the target tracking scaling policy option. This is where it is asking you that the scaling should be done on basis what? We have already discussed that the scaling will happen with respect to the CPU utilization. Of course, we can choose the CPU, or we can choose the network, or we can choose the network in or network out. We can even choose the load balancer, the count request, so on so on. There are four different ways how we can choose the scaling policy. However, the CPU is the main concern resource that we need to be focused on. Obviously, right? If the CPU touches 100%, then the server becomes slow. So this is the important metric that we need to focus on. Even in real time, we 90% will be using the CPU based scaling policy only, but just for interview sake, we need to know that it will support for three more as well. So if let's say if the network is high, then there is no much advantage you creating a one more server, because the another server will bring you a one more CPU or a memory capacity, right? So we will not get much advantage in doing the scaling just for the network purpose, correct? That's the reason. And as of now, only these four are the one which is supporting by the AWS. You will not see the option to do the scale out or scaling with respect to the memory utilization. You don't see that option here. So let me choose the, if average CPU utilization is going beyond 80%, then it has to do the scale out. If the average CPU utilization going less than 80%, then it has to do the scale in. You don't need to give a explicit scale out and scale in. If you give 80, it assumes that more than 80 scale out, less than 80 scale in. That is how it will understand, and accordingly the scale out and scale in policies will be created and the auto scaling group will works for you. So to create a CloudWatch alarm, you don't need to go to CloudWatch and create it there. If you specify this information, the AWS will create a required CloudWatch alarm having 80% as a threshold value automatically for you. All you need to set up, just mention that average CPU utilization, the threshold value is 80, then that's it. Scroll down. Let me go to next. There are few options are available here which are very optional, very not that much important at this time, so I'm not considering them at this time. Go to next. This step is all about sending the notification. Let's say when a auto scaling group is creating a new server, I want to know that when it is creating a new server, I want to know when the server is getting terminated, correct? So that is where we can click on add a notification. This is where you need to choose a SNS topic. If you have an SNS topic already created, then that SNS topic has to be chosen from the list, right? So then you need to choose when you need to get a notification. When a EC2 launch is happening, I need a notification. When it is terminating, I need a notification. When for some reason, if autoscaling not able to create a new server or not able to terminate a server, in these four cases, I need to get a email notification. That is how we need to set up the autoscaling group event types and the respect to SNS topic to whom the notification has to be sent out. Go to next. This is just a tagging, so just to identify, let's say the name, this is ASC server. Go to next. This is the review. I have chosen that the auto scaling group should use the launcher configuration, should be deploying it into my VPC into these subnets, no load balancer as of now, and these are the minimum and the maximum numbers that it has to maintain. These are the scaling policies. The threshold value is 80%, and these are the notifications that needs to be set up. That's it. Now let me click on create a auto scaling group. I got an error saying that auto scaling group could not be created. One or more security group in the launch configuration are not linked. Great. I'm getting this error every time because uh, we are creating the security group automatically, and that is getting created in the different VPCs. I'll show what does it mean. For now, let me cancel this. I think let me go to the other window. All the resources must be in the same VPC. Hope you know this point, right? But what is happened, right? If I go to the launch configuration, the one which we created, see, this is the launch configuration that I have created, right? If I look into my launch configuration details, you see the security group that was auto created for you. If I look into this security group, right? So let's see the security group is created in which VPC. You see, the security group is actually created in a VPC ending with AB8. But what is our VPC, right? If you see your VPC is ending with EF1, but the security group was created in a VPC ending with AB1. That means the security group that is currently using by my launch configuration is in the different VPC, and you are setting up the auto scaling group in your VPC, and hence it is failing to create. Now what to do? So I need to create a security group in your own VPC. That's the thing. So I need to replace this security group with the one more security group, right, which will be in your VPC. I'll do that. So maybe I cannot use the security group now. So explicitly, I will create a security group here. Let's say DPT4 security group 01, right? And this is where I need to choose the VPC. See, this is the default VPC, that's why it is taken there. I don't want this default VPC. I need my custom VPC this time. Select the inbound rule. I need to allow the port number SSH. I need to allow the port number HTTP. Allow them from anywhere. The outbound traffic we don't need to touch. By default, all the outbound traffic is allowed in the security groups. The description, this SZ for auto scaling groups. So create a new security group which is in your VPC now. Now the launch configuration was already created, right? The launch configuration is using the security group which is in different VPC. Now I need to change this. Good that we got this problem, because once the launch configuration is created, we cannot edit. This cannot be edited. Now you need to create your new launch configuration only, right? So what I can do, right, because the AWS is not allowing to edit this launch configuration, I can simply go and click on copy the launch configuration. That way the launch configuration will be copied as a new launch configuration with the same data. Now we can do some changes. I'm just giving a new name for this. See, the advantage is all the details are came automatically. The AMI, instance type, the role, maybe the user data, right? And the EBS volume, the security group. You see now, here I am trying to, you know, remove the existing selected security groups, if any. You see, this was the security group was selected some time back. I don't want it because that is in a different VPC. Now let me choose the security group, right? I think this is the one. I think not that one. This is the one, right? We can see the description. This security group for auto scaling group. Yes, this is the right one. So now I'm changing the security group and let it all other details as it is and create a launch configuration. Correct. Now again you start creating a auto scaling group. Every resource must be in the same VPC. Now while creating a launch configuration, let me auto scaling group, let me give dpt for ASG. I want to use the launch configuration. Sometime back I cancel the operation, right? That's the reason. Now you see there are two launch configurations are available. The first one was using the security group in a different VPC. Now we created a one more launch configuration with a new security group which is in your VPC. So select that. Now deploy that it into your VPC. Select the private subnet 01 and private subnet 02. Go to next. I don't have any load balancer for now. Go to next. I need 1 minimum and let's say a 6 maximum. I want to enable the scaling policies for average CPU utilization for 80% threshold. Go to next. Add a notification, send the notification to the SNS topic on all these 4 events. Go to next. Add a tag, maybe the name of these will be dpt, let's say dpt4-asg. Go to next. Now review the details and let's start creating a auto scaling group. You see here guys, it's very exciting to look into this output. The auto scaling group is created. Currently the minimum is 1, maximum is 6, the desired capacity is 1. That means there are no servers at the moment in my auto scaling group, but as per the minimum number, it has to have at least one server, right? That is where the auto scaling group started updating the capacity. So it started creating a server for you automatically now, because it has to maintain one server at least. Correct. So now if you do a refresh here, you see now the number of instances are 1. That means the auto scaling group is now have created a new server for you automatically with the help of the launch configuration that was provided. The server is deployed it into a private subnets. So here if you just do a activity tab, this UI looks crazy, so it's better to click on the name and go inside, right? If you go to the activity tab of your auto scaling group, right, it says that it is actually sending a message to this particular topic. Why? The launch is done. I said that when the launch is done, it has to send a notification that is done. And you can see the history that yes, the launching a new EC2 server is done, and this is the instance ID that was created, and this is the details why the launch is done, because it is updating the capacity from 0 to 1, because it has to maintain at least one server, and there was no server at the time of creating a auto scaling group, Now it is changing that capacity from 0 to 1 and is maintaining at least one server in the auto scaling group. If you go to this instance management tab, it will give you exactly which server was created. You see, this is the server got created automatically and it is in service at the moment, and it is created with t2.micro as per the launch configuration that was provided. Good. Now if I go to the EC2 dashboard and see the list of EC2 instances that are running, you can see that the dpt4-asg is the tag, and I can see that the server was deployed by the auto scaling group. It is actually deployed it into 1B availability zone, and you can see that it is deployed it into the second private subnet that was chosen. It is not having a public IP because the server is deployed it into the private subnet. I'm sure if everything is configured properly, then the user data script will be executed and the packages will be installed with the help of the Nat Gateway, and the server is now fully ready to start serving the website on a port number 80. Because this is a private server which is now being managed by the autoscaling group, now to access this website by the user request always should come through a load balancer. The autoscaling group is intelligent enough in choosing the subnet automatically. The autoscaling group may deploy it into a first private subnet or may it into a second private subnet. Let it choose by default. We cannot control that. It will choose any one of the subnet as per their choice, and the AWS will take care of that and will be deploying too. But let's say if you are having two servers, then it will ensure that one will be in one subnet, the other one will be in another subnet. That balancing that definitely will do by auto scaling group. But if you have only one server, then it will choose randomly any one of the subnet that it has to, because there are two subnets that I have given to my auto scaling group. As per this architecture, right? The auto scaling group is done. Now the next thing is, right, we need to create a load balancer, correct? Let me go and create a load balancer now. In the EC2, here you can see the load balancing and we can see the option called load balancers. In the load balancer tab, right, you will get an option to create a load balancer. Let me click on create a load balancer. AWS is providing a load balancer of type application load balancer, network load balancer, gateway load balancer, a classic load balancer. There are 4 type of load balancers are currently supported by the AWS. Why 4? Just to make you guys confusing, correct? Obviously one will be suffice, but there are many to meet the different business requirements. So we don't need to worry about all the different type of load balancer differences at the moment. The load balancer that I have explained is the network load balancer. Whatever we learn in the architecture, that the load balancer will have a target group and so on so on. This is the NLB, network load balancer. So let me go ahead and create a network load balancer now. And again, as I said, don't worry about the other load balancer and how they works. The differences will see in different sessions. For now, let me go and create a network load balancer. That is what I wanted to deploy in this particular design. Select the network load balancer. Now give the name of your network load balancer. In the short, let me call this as NLB. Now tell me guys, the load balancer should be a internet facing or internal? I am getting two options here. The load balancer should be internet facing, right? Because the load balancer should be capable to receive the request from the public internet from where the people are accessing my website. So choose internet facing. Where we to choose internal, we'll discuss in the different lecture again. That's again come with a different architecture. So the internet facing, scroll down. So this is where we need to specify the listeners. I said that the load balancer will be receiving the request on a specific port number, right? That is what we need to say here. Hey load balancer, receive the traffic on a port number 80. So select port number 80 here. We can choose the different protocol if you want. So for now, TCP is the ideal. Yeah, I think the TCP will be ideal for now. The TLS is a different discussion that requires some certificates. So for now, let me go for TCP. This is where we need to specify the availability zone. The load balancer has to do the load distribution to which availability zones. The load balancer should be deployed it into my custom VPC. In that VPC, the load balancer has to distribute the traffic to 1A availability zone and it has to distribute the traffic to 1B availability zone. In 1A availability zone, we need to select the subnet. Tell me guys, I need to select public or private subnet here. So obviously now I need to select the public subnet, and in the second zone again I need to select the public subnet so that the load balancer deployed into these public subnets can have access to a public internet space and can also route the traffic to the backend availability zones. To have a high availability even in case of the zone failure, I am choosing the two different zones for the best practices purpose. Now scroll down and go to the next. The step number 6 is not required at the moment. The step number 6 is all about the security certificates. The security certificate stuff I'll be discussing in a later session. For now, skip this particular step number 2. Step number 3 is all about configuring the routing. If you look into my architecture, I clearly explained that while you are creating a load balancer, you need to specify the port, availability zones, then the routing. As part of the routing, this is where we need to create a target group. Let's say I'm creating a target group called DPT4 NLB target group 01. So that target group will have a EC2 instances as a targets. So I'm choosing instance as a type. The target group will be listening on port number 80. That is what we need to choose the port number that it has to listen on. And this is where we need to define the health check settings, guys. That means how my target group know that which server is healthy, which server is unhealthy, correct? Sometime back I said that when you have two servers in your group, right, the request will come to the healthy server only. If the server is not healthy, then the request will not go to the server. How my target group know that which is healthy, which is not healthy? That is something you need to define the health check settings here. How a target group has to determine the health status of the server. Quickly, can you tell me guys in the chat window how we consider the server is healthy? If I send a request to 80 number, if I get a response, then I can consider that the server is healthy, right? Yes or no? Because my end user is accessing the website, the end user is always wanted to hit on port number 80 only. I will not care about 22 is working or not. I'll not care about the ping is working or not. I'll not care about any other port. I only care about the port number 80 reachability because the port number 80 is the one which is serving my business to the end user. Hope you get me. Just by using the ping, I'll not know exactly the server is healthy or not. The server may be reachable. Let's say the server is reachable, but the port number 80 is down. Do you think the server is healthy? No, right? The healthy in the sense is all in terms of the business perspective. Whether my user is able to access my website or not, that is the goal that we have here. I don't care about any other health checks. So I need to be worry only on a port number 80, nothing else. So here to my target group, I'm telling that, hey, right, look into the traffic port. The traffic port in the sense the port number 80 only. So it keep on checking for the port number 80, right? The port number 80 is reachable or not. That is how it will be checking. If the port number 80 is reachable, yes, the server is healthy. That is how it will come for a conclusion. So how frequently it has to check for the health status of the port number 80? That is something we can define the interval. Every 10 seconds once it will be keep checking the port number 80 is healthy or not. If the port number 80 is responding, yes, the server is healthy. If the port number 80 is not responding, then the server is unhealthy. That is how we determine, and the target group responsibility to keep on checking the port number 80 health status by sending some dummy heartbeat packets to the port number 80 on every second 10 seconds once as per the interval that you have defined. So there is a few more things here like the healthy threshold and unhealthy threshold and all. So it's all about, right? Let's say the target group is sending some heartbeat packets to the server to check the server is healthy or not. Let's say the server is not responding. Assume like the target group is sending some packet to the server on port number 80. Let's say the server is not responding. Should we consider that the server is unhealthy? Right? No, we should not come for a conclusion that the server is unhealthy. Of course, you have not received the response. You have not received the response maybe due to the server was very busy in doing some other activity. Maybe that is not responding but for you. So we should not consider that the server is unhealthy. So we need to define the unhealthy and healthy threshold values. Let's say if I give the threshold value is 3, that means every 10 seconds once it is checking for the port number 80 status continuously for 3 times. If it gets the positive response, then the server is healthy. Continuously 3 times, if it is not getting the response, then that server is unhealthy. That is how we need to define the healthy and unhealthy threshold values. It's up to you. You want to keep it 3 or 4 or 5 or 1, you can just do the changes. Usually you don't care much these numbers in real time too, so mostly it will be 2 in the real time. 2 times if I'm not getting the response, the server is unhealthy. 2 times if I'm getting the response, then the server is healthy. That is how you can define the healthy and unhealthy threshold. Go to next. This is where it is asking for registering the target, guys. That means tell me to which server the traffic has to go. Tell me guys, do I need to choose the server here manually? So the target group will allow you to add a server to the target groups. Let's say I can select the server which I wanted to add to this target group and I'll click on add to registered. Now this server is added to the target group. The target group will now start looking for the health status of this server, and the load balancer will start distributing the traffic to this server. But my question is, do I need to add the server to the target group manually? I'll show you this diagram. So this is the target group. So do I need to add this server to the target group manually? No, because I'm not maintaining a standard number of servers. The servers may be 1, maybe 2, maybe 3, 4, 5, 6. The number of servers will be dynamically changing with the help of the scaling policies in the auto scaling group. So You should not add the servers to the target group manually. So I'm not adding any servers to the target group now. I'm just creating a empty target group at the moment. Go next. Review and create a load balancer. Now you should be able to see that AWS is creating a network load balancer. AWS is creating a network load balancer and it is in the state of provisioning. It takes some 1 or 2 minutes to create a load balancer fully. The listener tab will tell you that the load balancer is listening on port number 80. That request is forwarding to this target group. Any request that comes to port number 80 that is forwarding to this particular target group. Now, if you do a little scroll down and if you go to this target group section, it will show you the target group that was created some time back. You can see the target group that was created. You can see the target. The target section is currently empty, right? There are no servers added to the target group. This is empty at this moment. Why? I have not added anything. Now this is the time you have done a load balancer creation. You have done a target group creation. The load balancer know that when the request come to port number 80, that request should go to which target group. All the setup is done. The only a pending is this one. I need to attach this target group to the auto scaling group. When you attach the target group to the auto scaling group, then whatever the servers that are part of this auto scaling group will be auto identified by the target group. The server will be added to the target group. This is the only integration that we need to do. Let me do that now. Go to the auto scaling group because I need to inform to auto scaling group, hey auto scaling group, this is the load balancer or a target group that I am using. In the auto scaling group, if you do a little scroll down in the load balancing section, as of now there are no target groups. Edit the load balancing section. You remember I skipped this option right at the time of creating a auto scaling group. Now here you need to choose the load balancer type, choose the target group. You see, this is the target group that was created some time back. That target group now I'm attaching to my auto scaling group and just update it. That's it. Now the target group automatically identify that there is one server in the auto scaling group. That server will be become the target. So now if you go back to the target group, right? In the target group, if you look into the targets, you should be able to see the server. So let me see how I can navigate to the upper side. You see now the server is now appearing in the target section. Of course, currently the server status is initial and you can see that the target registration is in progress. What does it mean? It is now doing the health check, right? The target group is checking the health of this server. If the port number 80 is reachable and it is working, then the status will become healthy. If the port number 80 is not reachable for some reason, then the status will become unhealthy. That's how it will decide the server is healthy or not, and only the healthy server will receive the traffic. The unhealthy server will not receive the traffic. That is how the target group will perform the routing. So let me refresh again. So usually take some time to understand that the server is healthy or not. So we'll wait for some time. Am I done everything? I have a auto scaling group which will be taking care of routing the traffic to, routing the traffic to, sorry, which is scaling the servers based on the business load. And the target group is the one which is looking after and adding that servers into the target group that is attached to the load balancer. Now the only pending this one, correct? Whenever my user is browsing my website, the request should come to whom? The request should come to my load balancer, right? That is something now I need to add. How to do that? If you go to the load balancers, right? This is the load balancer that is created, and if you see the load balancer, it has a name. You see the name? Remember, the load balancer will never ever provide you the IP address. Like EC2 was giving a IP for you, right? And that IP you are adding in the route 53 as a record, correct? To route the traffic to the server. So the load balancer will never give you the IP. The load balancer will give you the DNS name. So this is the name that I need to use in a route 53 to configure the routing. Take this name. This is my load balancer to which load balancer the traffic has to be routed, right? Then go to the route 53, go to your hosted zone, right? And which domain name that you want to provide to the end users to start accessing your website, right? Go to that particular hosted zone. You need to create a record. Already some records were there which were created previously. I'm just deleting them just to avoid the confusion. Now I need to create a record here. Let's say if anyone is browsing www.cloudcodes.com, then that has to be pointing to where? That has to be pointing to my load balancer. So give the load balancer name as a value. Now tell me guys, what is the type of the record here? A record or a CNAME record? We already discussed this, right? If one name is converting to a another name, it should be a CNAME. So you need to create a CNAME record pointing to your load balancer. So if anyone is browsing www.cloudcourse.com, that is pointing to the load balancer. The load balancer will take care of routing to the target group. The target group will take care of routing to the healthy server, whichever is healthy. The server is actually being managed by the auto scaling group. So let me create a record here. Now I'm done everything. The only thing is I'm curious to know my server is healthy or not. You see now the server is showing as healthy. Good. Then your load balancer is now can start serving the traffic to this particular EC2 server. How it became healthy, guys? I did not log into the server at all, right, to install my commands, right? I have not done anything installing the HDBD packages, starting the services, so on, so on. All that part is done through a user data. Now let me try www.cloudcourse.com. Excellent. You can see the beauty of the AWS cloud now. Without me logging into the Linux OS, I'm able to configure everything whatever I needed through the AWS only. And finally, my website also live. And this website is now highly available because the request is going through multiple levels. The request is going to the load balancer, it is giving to target group. The target group is actually checking whichever is healthy, that servers are actually managing by the auto scaling group. This is the backend infrastructure that is maintained to serve this website. The end user is able to access this server, guys. I mean to say the end user is able to access my website is accessible. Now tell me, I want to logging into the EC2 server where my website is deployed. How do I log in? I cannot log in, right? Why I cannot log in? Because if I want to log in, I need to access port number 22, and that is in a private subnet now, correct? Via the load balancer, I'm able to access my website. That is working fine. But me as an administrator, if I want to logging into the server to do some changes, right? I cannot logging in directly because that is having a private IP. I cannot log in via the load balancer. The load balancer is always for the end people who wanted to access the web services. If you want to log in, you have to go through via the best and host, or if you have a role configured giving the access to the session manager, through the session manager you need to get into the server. That is how now we need to get into your private servers. For now, to make it more simple, right, let me create a best and host quickly, correct? Without a best and I cannot log in, and again updating the role session manager, that will take some time to make the list available. It's a little time consuming process at the moment. So quickly I'm going to deploy a best and host. That way through a best and host I should be able to logging into my private server. I need one server, deploy it into my VPC. I'm deploying it into the public subnet, right? I need a default public IP enabled because I'm just using it for the bastion purpose. And the port number 22 should be accessible. Now let me go and start deploying the server. Let me launch the server. So quickly I got a bastion host now, right? Let me make this name as bastion. Now let me take this public IP. Let me logging into the bastion host. I'm integrating multiple things today, guys. If you have already done these labs, today's session will be little easier, right? So let me logging into the server. EC2 hyphen user, right? So now this is the bastion host, and from this bastion host now I want to log in into my private server, right? So I need a PEM formatted key. So I'm not sure if I have that key available. No, I would have been no generated the PEM key in keep it in my local. That way I need not to convert every time, correct? So I think let me convert the key to the PEM format in my Windows machine only. Well, so let me click on load, and I'm just attaching the current PPK formatted key. Now let me go to the conversions, export open SSH key. Now click on yes. Now it will come as dpt4.pem format. Let me save that, and that's it. I should be done. So now let me see dpt4.pem format. Open file location. So this is the PEM key. Let me edit it. This is now should be in the PEM format. vi dpt4.pem key. I got that key. Let me put that key here. The permission should be 400 for security reasons. ssh-i dpt4.pem, and now my server IP. All these you already familiar, guys. Okay. So this is the server which is having a private IP. Let me logging in as EC2 user. Let me accept it. You successfully logged into the private server. You do switch to the root. Now let me install EPEL, right? Why I'm installing EPEL? I wanted to show you the scaling, right? What I do now, right? I will install the stress command. Okay, I will install the stress command on the private server which is currently serving my website. I'll put some load. I need to verify, right, my auto scaling works or not. Correct. So now I'm just using the stress command. This is the stress command, right? So let me put some load for number of seconds. Now I'm putting more load on the server. Now the CPU utilization will go high definitely. When the usage go high and the CloudWatch alarm will detect that the usage is going beyond 80%, then that will inform to auto scaling. The auto scaling has to do the scale out, and if the scale out will happen, I should get one more server added. Currently, my auto scaling is having only one server, right? I think if I go to my auto scaling group, currently it has only one server. When there is more load come in, obviously the alarm will trigger and it will perform the scale out, and I should get one more server. That is how we can do the verification how the scaling is happening. The end user who is accessing the website, they'll not know anything. They're simply accessing the website. In the backend, if more number of people are accessing the website, the scale out is happening due to the scale out alarms, and that is how the infrastructure is scaling horizontally to give you a scalable application. You will never know the difference whether your request is going to the first server or second server or third server. The load balancer will take care of, or a target group will take care of routing your request to the backend number of servers if it is having more than one server. So you will be getting the response from any one of the server. You may be still having a question that how come the number of multiple servers will giving the same website? Because of the launch configuration, right? The launch configuration, the user data is pulling the same code, right? That means all the servers who are part of my auto scaling group are now maintaining the same website code, same data. So it has to give you, of course, same website code. So the request go to any server, you should get website. The request go to this server or this server, the end user should get the same website because both servers are deployed with the same website code, because both servers are created with the same user data, same launching configuration. So no difference in terms of giving the services to the clients. Even tomorrow, if the server gets terminated for some reason, you don't see any data loss. Tell me guys, am I storing any business data on my server at the moment? I have not stored anything, right? Whatever is needed all come from my S3, right? As part of the launch process, whatever is needed for me, I'm picking it from S3. So nothing that I'm storing in the server level. So if the server gets destroyed because of the scaling operation, I don't see any data loss. In fact, that's the best practice. You should not store any business related data in the EC2 server which is part of the auto scaling group. Single statement. Why? The server may go for termination anytime. So you should never ever store the data in the server managing by the auto scaling group. Always you need to store the data outside of the server somewhere. It may be S3 or different place. You need to get the data onto the server as part of the launch process using the user data. That way you don't see any data loss. If the new server comes in, it pull the data again from S3 or from different sources. The server will be ready, right, as per the business. That is how I'm achieving the high availability, scalability, security for my business application. So all what I'm waiting is it will do the scale out and I'll get a new server after some time. Of course, the CloudWatch alarm will take some time to trigger the alarm. As and when the alarm is triggered, it will start creating the new server for you. Maybe you can watch out for the CloudWatch alarm status. What is the current state of the CloudWatch alarm? Hope this is clear for now. The today discussion I have included many things: IAM, SNS, CloudWatch, EC2, VPC, many other, right? You see now here I have the CloudWatch alarms are created, right? You can see the alarms are created. As of now, the alarms are in OK state. Just wait for some time. So automatically the alarm will become the alarm state. Currently it is in OK. When it becomes the alarm state, then the auto scaling will start kicking and start creating a new server for you. I think by default it is 3 data points within 3 minutes. That means 3 into 3, almost 9 minutes, right? That means it will take at least 10 minutes, almost 10 minutes to understand that the usage is more than 80. Then the alarm will be triggered. So we need to wait for that time. Then the rest of the things will make it automated. So that's the story for today, guys. And I will be giving you the assessment based on these scenarios. Work it out and implement the scenario. Whatever I have discussed today is the main important scope that we need to know in AWS, because this architecture is involving everything what you need almost. It is touching IAM, CloudWatch, SNS, EC2, VPC, networking, autoscaling, load balance stuff, maybe Route 53, you see, S3 as well. Many things are included in the single architecture to make a complete fruitful website or web services. So
Uh,
quickly, if any questions, do let me know, or else we are good for now. Probably we'll wrap this call in next 5 minutes. So okay, go ahead,
okay.
Saurabh.
Yeah. So if there is any change in the code, so how we are going to do that? Are we going to change the uh, launch configuration itself, or are we going to change the file itself on the S3?
You need to change the file in S3. Okay, and if you are adding a new file, let's say, you need to put that in S3 and
Mm-hmm.
update your user data. That means you need to update the launch configuration only. You need to update the launch configuration. When you are updating the launch configuration, then the current server is not included with that, right? So
Yeah.
how the currently running server will get that configuration, correct? So the step number one, you update the launch configuration with the new requirement that you have. Step number two, go and terminate the server manually. You terminate the server. Whenever you terminate the server, it will recreate a server for you automatically, right? Because that is the auto scaling group responsibility. When it is creating a new server, the new server will come up with the new launch configuration, and that come with a new configuration as per the requirement.
Okay. So if the servers are already in if the servers are already in more number, for example, if the maximum number is 6 over here, so we need to change the code only when the flow is low, right? Means the minimum number of servers are up
Obviously.
right now. Yeah. Okay.
Obviously. So that's the reason this kind of maintenance activities will be done on maybe Sunday, maybe after business hours, maybe midnight. That is how the schedules will happen. That time we need to change the auto scaling group launch configuration. Then you terminate one server, it will create a one more server, right? So that
Okay.
is how we need to do the rolling fashion. So the end user will not get any downtime, because while you are setting down one server, the other servers are there to serve the website for you, right? So you don't see
Yeah.
any business impact.
Okay.
Here this Amir. You showed us how to create a list. Can you show how to dismantle it? Because we will just keep deleting the servers and it will
Uh,
how to dismantle this setup.
yeah, that's the great thing, really. You see now the alarm is in alarm state, guys, and now if I go and look for my auto scaling group, you see now there are two servers are created. Those two servers will now be a part of your target group automatically, right? So if I go to my target group, in the target group, now I should be able to see servers for me, right? So if I do here, if I come to my target group, it should have a 2 servers. You see, 2 servers. The other server will come to the healthy after some time. It will do some registration process. Now the traffic will be distributed to 2 servers. Though some scale out is happening behind the screens, you will not see the difference from the end user. The end user will just accessing the website. The request will go to any one of the server whichever is healthy in the backend. That is how it is taken care of. After some time, if the load is less, then obviously, right, the scale in will happen and one server will be get terminated. Now, so to do this cleanup, right, let's say you have to go to the auto scaling group, right? Because if you terminate a server, it will create a server again because it has to maintain the minimum number of servers, right? So we need to delete the auto scaling group. So go and start, you know, deleting the auto scaling group, then that will delete the servers also automatically. So we don't need to delete the servers manually. Delete auto scaling group, that will terminate the servers that it is managing for you, and that is how we need to do the cleanup process. And then we need to delete the target group and the load balancer as well. So the load balancer is chargeable, and of course it is part of the free tier for certain limitations, but it always a good idea to go and do the cleanup of your load balancer as well. Just need to delete them, that's it, right? So that's the story, guys. And answering to Radha, yes, always it will pick up the latest version only, right? By default, only the latest version will be supplied by S3. The previous versions will be available, but only the latest is the one which the customers will be accessing by default. Well, team, I think I'm closing the call in next 2 minutes, right? Probably take a breath and looking into this architecture and try to deploy this. And by Monday, we'll come up with a new different story.
Sir, I have one
Thank you.
question.
Yes.
Yes, sir. It is just a basic question regarding the the term EC2, which is Elastic Compute Cloud. So here, by elastic means increasing computing capacity based on scaling up and scaling down by the means of auto scaling, or something within the EC2 itself.
Okay. Now that name is not with the name of with the concept of auto scaling. That is with the concept of vertical scaling, right? For the same
Yes.
server, you are able to change the instance type as and when needed, right? Because of that flexibility, they have given the name called Elastic Compute Cloud because you are able to change the capacity whenever you want it.
Okay, okay. So we can just go inside the configuration. We can increase the CPU and all, correct?
Correct.
Okay, okay. Yeah, that is what I wanted to clarify. Thank you, sir.
Thank you. And the alarms are created automatically for you when you are setting up the scaling policies. You don't need to create alarms in CloudWatch manually. Those will be created for you when you are creating the scaling policies at the time of creating a auto scaling group.
Hi, Priya. This is Ashok.
Yeah.
See, if we want to maintain an application data, we need to attach EBS volumes, right? So how
So
do we maintain
application data will come in a different discussion, guys. Okay. Even today I'm showing the S3, but S3 is not a complete solution to store the data. I'll talk about the data part later, where we need to exactly store the data. Yeah. Thank you.